Let's conclude our discussion of programming in Unity by talking about some of the Unity-specific things you should understand. Overall, we say that Unity is an event-driven environment. You often add functions to your classes to respond to events that occur while the game is playing, such as start, which is called when the game object starts in the scene, and update, which is called every time through the game event loop. There are a few other events that happen when you start playing, including awake, unenable, and start in that order. These are great places to set up things, like initialize variables. During the game event loop, the update and late update events happen in that order. This is a great way to do things or check on things while the game is playing. And there are several other events that you can respond to, such as fixed update for updates that are synchronized with the physics engine, and events for collisions and triggers, as well as events for mouse input on game objects, such as mouse up and mouse down. And there are many other built-in events. And you can also create and respond to your own custom events as well. One common thing that we do in scripts is modify game objects in some way. When a script is attached to a game object, we can reference the game object in the script as this.gameObject, or just gameObject for short. For example, these two start functions do the exact same thing. They set the game object that the script is attached to inactive. This is the same thing as clicking the active-inactive checkbox in the inspector, except of course it is done dynamically at playtime. In this script, the name of the game object is outputted to the console window in the Unity editor twice. That is, both lines do the same thing. If we want to reference a game object that the script is not attached to, we can do this in a number of ways. We can have a public variable of type gameObject that we attach to another game object or prefab in the Unity editor. Or we can search for the game object using gameObject.find to search for a game object by name. Or we can search for the game object using gameObject.findWithTag to search for a game object with a particular tag. With both of the find techniques, you need to make sure that you only have one game object with a name or tag that you're searching for. Otherwise, you're not sure which game object you'll get a reference to. You can see in this example that once we have the reference to the game objects, we can call the setActive function in the same way. Once we have a reference to a game object, we often want to modify a component of that game object. Every property that you see in the Unity editor for a component can be referenced and often modified through code. For example, let's say we want to move a game object along the x-axis. We can do this through its transform. In code, we can reference the transform of a game object through the transform property of the game object, or gameObject.transform. The transform property has a position property, which in turn has an x property. So, gameObject.transform.position.x is how we would reference or change the x position of a game object. We can do this in the update function so the game object moves every frame update. It turns out that the transform class has a built-in translate function that will essentially do the same thing. So alternatively, we could use that to move the game object along the x-axis. The function takes 3 arguments, one for x, one for y, and one for z. As you can see here, I'm only modifying the x. Not all components are properties of the game object, like transform. To get a reference to any component type on a game object, you can use the gameObject.getComponent function and then specify the type of the component. Once you do that, you can then manipulate the component. For example, this script gets a reference to the rigid body component attached to the game object and sets it to a variable named RB. It then modifies the useGravity variable, setting it to true or on. Another way to reference a component is to set up a public variable in your class. This will make the variable appear in the Unity Editor Inspector. You can then drag and drop a game object with the specified component to the variable in the inspector. Here are common component types that you might reference in code. Once you get a reference to the component, you can use the component's properties and methods to do things dynamically as the game plays. A lot of game coding is simply manipulating game objects and their components. When you're writing Unity scripts, The scripting API documentation that comes with Unity and is available on the web is an absolutely essential resource. You can use it to look up, for example, any component type and then find the properties and methods that allow you to work with the component through code. Another common thing that you want to do in code is to spawn or instantiate game objects into the game scene. This can be done, for example, to spawn enemies or create projectiles that the player fires. Here is an example script that instantiates a prefab. Once you attach this script to a game object, you could then set the prefab variable in the Unity editor to be the prefab that you want to spawn. While the game is playing, this code will run on each frame update. It checks to see if the user is pushing the fire button. If so, then it will get the current position and rotation of the game object that the script is attached to. Then it will instantiate a new game object based on the prefab at this position and rotation. There are ways to simplify this code, but I wrote it more verbose to hopefully help in understanding of the process. If some of the concepts we just discussed are very foreign to you, don't worry, you're learning a new language. Remember, it takes time and effort to get up that learning curve. Also, remember, Unity has excellent documentation. I recommend that you reference the online documentation often, especially the API scripting reference. Microsoft also maintains good online documentation on C# in general. Unity also has a vibrant community with a very active forum. If you have a question on how to do something, search the forums. Someone probably already has asked the question and you can find an answer. If you cannot find an answer, you can always post your question to the forums and someone will likely get back to you. Or just Google it. There are many great programming resources out there, such as Stack Overflow, which also has very active forums. There are also many great video tutorials on YouTube. Wow, we just did a rapid-fire quick start of programming in C# with Unity. I hope your mind is not too blown. This lecture should give you the base knowledge needed to understand the code walkthroughs that we will be doing across the rest of the course. I recommend working through your current class assignment and then coming back and watching this lecture again. Like learning any new language, it takes practice, experience, and some patience to get good at it. Once again, this is not really a programming course, but hopefully this and the projects that you'll be doing will help improve your programming chops. No matter what your role, programmer, artist, or designer, the more programming that you know, the better off you'll be when it comes to game development. Happy coding!